This conference will now be recorded.
So yesterday we started with the different methods of expressing concentration. So how many methods are there?
5. 10.
Only 5 methods?
10, ma'am.
10 ma'am,
methods.
10 methods.
Yes. So methods of expressing concentration of solutions. We have 10 methods: percentage by weight, percentage by volume, weight by volume, mole fraction, parts per million, molarity, molality, normality, formality, and femal. So these are the different methods of expressing the concentration. And yesterday we started with percent by weight, that is percent by mass or percent by weight, one and the same. So what is percent by mass? Definition: it is the mass of solute divided by the mass of the solution, all multiplied by 100. So the formula is percent by mass is equal to mass of the solute divided by mass of the solution into 100. And we have discussed some examples. Remember, 3 examples we have discussed. So percent of solute divided by weight of solution into 100. So we will be expressing it in concentration. Next is percent by volume. So the symbol of percent by volume is V by V percent. So definition: it is defined as the volume of solute present in 100 ml of solution. So this will be calculated for 100 ml. The 100 ml is standard here. So how many volume of solute present in 100 ml of solution will give you volume by volume percent. That is nothing but percentage by volume. The formula for this is volume of solute divided by volume of solution into 100. So here only the changes, instead of weight we are taking here volume. So this method, that is volume by volume percent, this is widely used in determining the alcohol content of alcoholic drinks. So when you want to find out how many percent of alcohol is present in the given formulation, this volume by volume is very important. That is percentage by volume. The amount of alcohol in alcoholic beverages is expressed as the proof number. So we tell that as proof number. Alcohol proof number is 2 multiplied by percentage volume by volume. So we'll do some examples. Take down one example. A solution is prepared by mixing 50 ml of
And the solution is prepared
by mixing
Ma'am, repeat once again, ma'am.
a solution is prepared by mixing 50 ml of ethanol, ethanol, ethanol in 300 ml of distilled water. A solution is prepared by mixing 50 ml of ethanol in 300 ml of distilled water. Full stop. What is the percentage volume by volume? What is the percentage volume by volume? Concentration percent volume by volume concentration. if the proof number of the solution is 2% volume by volume. 2% volume by volume, V by V. So for this solution, that means answer I am telling. So what
Can you
is
please
given?
repeat it again, ma'am?
Okay. A solution is prepared by mixing 50 ml of 50 ml of ethanol in 300 ml of distilled water. To stop. What is the percentage volume by volume concentration if the proof number of the solution is 2% volume by volume? So first, what is given, we'll write down. So volume of solute is how much?
50 ml.
Volume of solute 50 ml. Ethanol is the solute here. So 50 ml volume of solute. Next, volume of solvent 300 ml.
300 ml.
Solvent is 300 ml. So what we need to find here? Percent concentration by volume. So we need to find this percent concentration by volume. And one more thing is also given, that is proof number is 2% volume by volume. So the formula is volume percent is equals to volume solute divided by volume solution into 100. So volume solute is 50 divided by volume solution is how much?
300.
No, it is 350.
350.
350.
Solution is solute plus solvent. So volume solvent it is given 300. Solution is 300 plus 50, 350 ml. So it will be 50 divided by 350 into 100. So how much it will be?
14.2%.
14.8.
Ma'am, 7.14 answer.
No, 14.28. How it will come 7? $50 divided by 350 into 100. How much will get?
14.2.
14.8.
14.28. Now they have given proof number 2. So this 2 has to be multiplied with your answer. 2 into 14.28. How much it is?
28.57.
28.56.
57.
Ma'am,
Okay, 56 or 57. So
Ma'am,
what is your
56.
percent? Volume by volume is 14.28% and the proof number is 28.5.
28.4.
Why
Ma'am, your voice.
all are getting different?
28.5.
28.57, ma'am.
Yes, 28.57. So next question. A wine contains, take down, a wine contains, WINE, a wine contains 12% alcohol by volume. A wine contains 12% alcohol by volume. Full stop. Calculate the number of milliliters of alcohol. Calculate the number of milliliters of alcohol in 350 ml of the wine. A wine contains 12% alcohol by volume. Calculate the number of milliliters of alcohol in 350 ml of the wine. So what's given here? Percent concentration of alcohol in wine. How much? Percent concentration of alcohol in wine is how much? 12%.
12%.
Yes. Then total volume of solution, that is wine. Total volume of wine 350 ml. Yes. Next, what is required? What you need to find out?
Volume of
Volume of alcohol in the solution. So how much volume of alcohol is present? You need to find out. So what will you do now?
42 ml.
Yes, it's correct. 42 ml. So how will you do? 350
Ma'am,
into
42 ml.
yes, 350 into 12 divided by 100.
100.
So it will be 42 ml. So there is 42 ml of alcohol in the wine. Next example. Rubbing alcohol. Rubbing alcohol. Is an aqueous solution. Rubbing alcohol is an aqueous solution containing 70% isopropyl alcohol.
Ma'am, containing
70% isopropyl alcohol by volume. Rubbing alcohol is an aqueous solution containing 70% isopropyl alcohol by volume. To stop. How would you prepare? How would you prepare 250 ml rubbing alcohol? How would you prepare 250 ml rubbing alcohol from pure isopropyl alcohol? How would you prepare 250 ml rubbing alcohol from pure isopropyl alcohol? So did you understand the question? So you need to prepare a rubbing alcohol. Rubbing alcohol is nothing but it's an aqueous solution which contains 70% isopropyl alcohol by volume. So you need to prepare like this 70% concentration of isopropyl alcohol containing rubbing alcohol of 250 ml. So 250 ml you need to prepare. So what you can do, we'll see. So what is given? Percent concentration of isopropyl alcohol in the solution. How much? 70%. Percent concentration of isopropyl alcohol in the solution should be 70%. That is given here. Next, total volume of solution is 250 ml. So that is also given here. So volume of water to be added to form 250 ml rubbing alcohol with 70% isopropyl alcohol. You need to find out how much water you need to mix it. to form this 70% isopropyl alcohol in 250 ml. So what is the solution? (70 ml isopropyl alcohol into 250 ml solution divided by 100. What do you get?
100.
175
175.
175.
Yes, 175 ml you got. So now
Yes,
you need
ma'am.
to prepare 250 ml. So 250 ml minus 175 is
75.
75.
prepare the solution. You need to add 75 ml of water and 175 ml of isopropyl alcohol to form 250 ml rubbing alcohol with 70% isopropyl alcohol. Understood?
Yes, ma'am.
So this is how you
Ma'am,
find out the yes.
Ma'am, due to network errors, I could not hear anything. Could you please explain the sum again?
Okay. So the question was you want to prepare a 250 ml rubbing alcohol. Okay. This 250 ml rubbing alcohol means it should have 70% isopropyl alcohol in it. So 70% isopropyl alcohol, if you want to prepare 250 ml, so how much water is required is the question. For that, we have used the same formula, that is volume percent. Volume solute divided by volume solution into 100. So what is given here? Percent concentration is given, that is 70%, and volume of solution is also given 250 ml. We need to find out the water, how much required. So if you substitute for this equation, so what happens? 70 divided by 100 into 250. So you'll get 175 ml. So this is 175 ml of isopropyl alcohol is needed to prepare 250 ml solution. So if you subtract 250 ml minus 175 ml, so what you get is remaining 75 ml is water. So this 75 ml of water is mixed with 175 ml of isopropyl alcohol to form 250 ml of rubbing alcohol.
Okay, ma'am. Thank you.
So next is weight by volume. So weight by volume means it is defined as the amount of solute present in 100 ml of solution. So it has an unit, that is mg per L, mg per liter. How many milligrams of solute is present in 100 ml of solution. So this is also multiplied by 100. The formula is weight of solute divided by volume of solution into 100. So this is very simple. Just you need to check for what is the weight of solute you are taking and how much quantity of solution you are dissolving and multiply it into 100. So that is the percent weight by volume. So example, if you take 5 grams sugar dissolved in 20 gram of water. So what is the weight by weight percent concentration of sugar in the solution? 5 divided by 25 into 100. So that is 20% weight by weight. So this is the weight by volume. Next is mole fraction. So what is mole fraction? It is the ratio of the number of moles of solute and the total number of moles of solute and solvent. So this is nothing but mole fraction. Before going to that, what do you mean by mole? What do you mean by mole?
Number of particles present in 1 gram of the sample.
Mole means nothing but molecular weight. Okay. Mole means molecular weight. So which compound you are taking, you have to check for its molecular weight. So that is the 1 mole. So how many moles of solute you are taking divided by total number of moles of solute plus solvent is the mole fraction. So moles of solute, total moles of all components. This can also be written. This is the number of moles of a compound divided by the total number of moles of all chemical species in the solution altogether. So here an example is given. So what are the mole fractions of the components of the solution formed when 92 grams of glycerol is mixed with 90 grams of water? So here the question is you have to find out mole fraction of the component. First you are taking 92 grams of glycerol and is mixing it with 90 grams of water. So for that we need to know the molecular weight. Molecular weight of water is 18. Molecular weight of glycerol is 92. So the solution 90 grams of water means, how will you find out? "90 into 1 divided by 18. So that is 5 moles of water. Similarly for glycerol, 92 grams into 1 mole divided by 92, that is equals to 1 mole of glycerol. So total moles is 5 plus 1, 6 moles. So water is, how much it is present? 0.833 and glycerol 0.167. So if you add these two, water plus glycerol, so you get approximately to 1. So if you get this 1, that means your calculation is correct. Next is parts per million. So the symbol is ppm. ppm is nothing but stands for parts per million. So it is defined as the parts of a component per million parts of the solution. That is nothing but, actually it is not 106, it is 10 to the power of 6. Sorry, it is 10 to the power of 6 million. So it is widely used when a solute is present in trace quantity, especially when you talk about the impurities. So we'll tell it is present in very less concentration, parts per million. So when you are talking about very trace quantities, we use this term parts per million. So the formula is mass of solute divided by mass of solution into 10 to the power of 6. So example, calculate the molar concentration of 2000 parts per million of what is Pb2 plus, what is Pb2 plus? It's nothing
Lead.
but lead. Lead is a heavy metal. Yes, lead is a heavy metal. So you need to check it. So 2000 divided by its atomic molecular weight, that is 207 into 1000. So what you get? Molar concentration is 0.0009 moles per liter. So you can see how less the quantity is. Yes or no? Till here, is it clear?
Yes, ma'am.
So next comes the important thing where we are using in our classes, both in practicals and theory, that is molarity. Molarity, the symbol we represent is capital M. Keep it in mind, we have small m also. So please don't forget when you are mentioning molarity, it is capital M. The definition of molarity. Molarity of any solution is number of moles of solute per liter of solution. So it is the number of moles of solute present in 1 liter of solution. It is nothing but molarity. Unit is moles per liter. Molarity is equal to number of moles of solute divided by volume of solution in liters. So you can also write moles divided by liter solution, will get the M. So what is the molarity of solution containing 0.32 moles of sodium chloride in 3.4 liter? Just 0.32 divided by 3.4. So whatever you get is 0.94 moles of molarity. So we'll take one example for this. How will you prepare? How will you prepare 1 molar sodium hydroxide solution? How do you prepare 1 molar sodium hydroxide solution? So can anyone tell how will you prepare 1 molar sodium hydroxide solution? So what is meant by molar? Just now I said, what do you mean by molar, molar?
Molecular weight.
Yes, molecular weight. What is the molecular weight of sodium hydroxide? So how will you find out the molecular weight of sodium hydroxide?
T.
Ma'am,
Yes.
sodium for sodium
Sodium
23.5.
hydroxide 40, ma'am.
Oxygen?
Then hydrogen
16.
Yes.
1.
Hydrogen?
1.
Yes. Altogether it will be 39.997. We will round it off to 40. Okay. Sodium hydroxide molecular weight is 40. Now you want to prepare 1 molar solution. How will you prepare 1 molar solution? Just you have to take molecular weight of sodium hydroxide. How much is molecular weight? 40 grams. So 40 grams of sodium hydroxide is dissolved in 1 liter of water, that is 1000 ml water. So you'll get 1 molar sodium hydroxide. Understood? Just you have to take molecular weight 40 grams and dissolve it in 1000 ml water. So whatever the solution you get is 1 molar solution. So one more example you take. Calculate the molar concentration. Calculate the molar concentration of a solution. Calculate the molar concentration of a solution that contains. Calculate the molar concentration of a solution that contains 15 grams of potassium hydroxide in 225 ml of solution. Calculate the molar concentration of a solution that contains 15 grams of potassium hydroxide in 225 ml of solution. So how will you find out the molar concentration now? First check for what is given. What is given here? Total amount of solution. It is how much? 225 ml. Next, mass of the solute. How much is given mass of the solute?
15 gram.
15 gram.
Yes, 15 grams of KOH. Now we need to find out first molecular weight of potassium hydroxide. What is the molecular weight of potassium hydroxide? Molecular weight of potassium is how much? 39. Oxygen
39.0.
16. So when it is after decimal 0 comes, neglect that 0. Take it as 39. Round up to 39. Oxygen 16, hydrogen 1. So total how much it is? KOH, molecular weight?
56.
Yes, 56. Now 15 divided by 225 into 56. How much you'll get?
Ma'am, 3.7. 3.73.
3.74.
15 divided by 225 divided by
3.73.
yes,
3.7, ma'am.
3.7.
3.7.
How you are getting 3.7? No. It's wrong.
3.98.
15 divided by what you are doing?
225.
So what you get?
0.06.
Again divided by 56.
0.001.
0.011.
Yes, ma'am. 01.
Into 1000.
1.19.
1.15. 1.15.
1.19, not 15.
19.
Ma'am, 1.19, ma'am.
So 1.19.
Yes, ma'am.
So you can round it off to 1.2, right?
Yes, ma'am.
So this is the molar, 1.2 molar. So how you got this? 15 grams of potassium hydroxide in 225 ml of solution. So write down 15 grams of KOH divided by 225 ml of solution. So this whole thing into 1 mole potassium hydroxide divided by 56 grams of potassium hydroxide. 1 mole of KOH is nothing but 56 grams of KOH. Again, into multiplied by 1000 ml solution. That's why it is 15 into 1 into 1000 divided by 225 into 56. So you'll get 1.19, that is round it off to 1.2. So 1.2 molar is the answer. Now take down one more question. Calculate the number of grams of sodium hydroxide. Calculate the number of grams of sodium hydroxide necessary to prepare. Calculate the number of grams of sodium hydroxide necessary to prepare 500 ml of 2 molar solution. 500 ml of 2 molar solution. Can anyone calculate and tell the answer? We want to prepare 2 molar sodium hydroxide solution of 500 ml volume. So how much sodium hydroxide you need to use? How will you calculate? Can you see my screen?
No, ma'am.
No.
And
No, ma'am.
No, ma'am.
okay,
No, ma'am.
okay, got it. How will you find? First one, what you need to do. So to prepare 1 molar solution, How much of sodium hydroxide is required? Now can you see?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
40 grams of Can you see the words?
Yes.
So
Yes,
40
ma'am.
grams of sodium hydroxide is dissolved in 1000 ml of water. You get 1 molar solution. So you don't know now how much grams of sodium hydroxide is required. X grams of sodium hydroxide dissolved in 1000 ml water will give you how much molar you want? The question? 2 molar. Yes.
Molar.
Yes. So here what is common? 1000 ml is common. You can strike out and you can cross multiply for x. X is equal to 40 into 2 divided by 1. So what will be the answer?
80.
So 80. So what is this 80?
Dissolved in 100 ml of water.
No, 80 grams of NaOH
80 grams of sodium hydroxide.
is dissolved in 1000
1000
ml
ml of water.
1000
water.
Water.
What you get? 2 molar.
2 molar.
Yes. Now what will be the answer?
40.
40.
So 40 grams of sodium hydroxide dissolved in 500 ml water. You will get 2 molar solution. is how you need to calculate step by step. If you do this, you will not go wrong. So one more question, you do it in this way only. Take down. Calculate the number of grams of sodium hydroxide. Calculate the number of grams of sodium hydroxide necessary to prepare. Calculate the number of grams of sodium hydroxide necessary to prepare 450 ml of 2.25 molar solution. The question is, calculate the number of grams of sodium hydroxide necessary or required to prepare 450 ml of 2.25 molar solution. So this is the question. Calculate the number of grams of sodium hydroxide necessary to prepare 450 ml of 2.25 molar solution. So do the calculation fast and let me know the answer. Tell the answer fast. So you can go with the same step how I have shown here. Similarly, you can do it.
Ma'am, 36, ma'am. 36 gram.
First, tell me for 2.25 molar, what is the required sodium
20 gram of
hydroxide in 1000 ml? First step,
Ma'am, 90 gram.
90 ಬರುತ್ತೆ ಮ್ಯಾಮ್. ಲಾಸ್ಟ್ ಆನ್ಸರ್ ಬಂದ್ಬಿಟ್ಟು
10.
And 36 gram of NaOH dissolved in water.
10 molar.
everyone got 90 for the first step?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Then
Yes, ma'am.
second step,
At 36 gram, ma'am.
gram.
Yes, ma'am. 36 gram of NaOH dissolved in water is 2.25 molar of solution.
Who is that getting some TV noise and all? Forty into 2.25 is 90 grams. So 90 into 450 divided by 1000. How much you get?
40.5, ma'am.
Yes, 40.5 is the answer.
40.5, ma'am.
36. How is
40.5, ma'am.
45.5.
40.5 is the
5
answer.
gram.
40.5 grams of sodium hydroxide should be dissolved in 450 ml of water to get 2.25 molar solution. It's not 36. So take down some homework. So these 5 questions you need to solve. Calculate the number of grams of sodium hydroxide necessary to prepare 250 ml of 2.25 molar solution. Calculate the number of grams of sodium hydroxide necessary to prepare 500 ml of 0.5 molar solution, 750 ml of 0.25 molar solution, 200 ml of 1 molar solution, 500 ml of 0.05 molar solution. So I need 2 steps. What I shown here. So these 2 steps I need. For all these questions, you need to do like that only and keep it ready. I will tell you how to send the homework. That is, I'll give you my mail ID. To that, you need to send it. I will send in the group.
Ma'am, I got the answer of second one, ma'am.
I want all the 5. Don't be hurry. You will take your time. Okay. All the 5 questions, you write it in a proper way. What I shown today, right? 2 steps. Write it in that manner only. Calculation will not go wrong. And one thing I need to tell. So here we are getting how much time you are there in the class. If you are there for 1 minute, if you are there for 15 minutes, or you are there for entire class, everything is recorded here. If you are not attending full class, the attendance will not be considered. Take it seriously. Try to attend the class from first to last. Don't leave in between. Everything is recorded here. And who is talking also will come to know. Everything is recorded. So if you are not answering while we are asking the questions, that will also be recorded. This is what your student-teacher interaction, and that is what the marks you are getting. If you are not interacting, you will lose your marks. Since this is online, if only I will teach, it is not good. So you should also respond, whatever the question I ask in between. And Shilpa ma'am was talking about making CR. So any volunteers who is interested to become a CR? One girl and one boy. We need 2. So anyone, if you are interested, you can message me in WhatsApp. So later I'll decide whom to make. So any doubts for today's class?
No, ma'am.
Okay.
No, ma'am.
No, ma'am.
All I understand.
Okay. Today, once again, you revise it. If you have any doubt in next class, you can ask me. Okay. I'll finish.
Ma'am, can we solve these questions using different method?
Different method in what? Like direct, without going through 2 steps?
Ma'am, that is, ma'am, a bit easier, ma'am.
It will be easier. If you go wrong, you'll lose the marks. It will be asked in the exam.
I mean, secondly, ma'am, we did using that method, ma'am.
No. Like in 5 marks, if they ask this question, if you're not writing step by step, you'll get less marks. If you want less marks, no issue.
Then we can't use formula directly and then solve.
Yes, you can use the formula. Formula method is also good. And this method, usually we are using in practice. That is practicals and all, we are using this method. So formula method, if you want, I'll discuss in the next class. But you'll be already studied in your PU, that is 12th standard. So I went for this method. Okay then.
So, ma'am, can we solve using those questions with formula method?
Yeah, you can solve with formula method.
Okay, ma'am. Okay, ma'am.
Yeah, you can write it and keep it ready. I'll tell you how to send to me later in the group. This will be taken as assignment also. This is considered as assignment also. So today only 62 members are getting the attendance out of 86. So if your attendance percentage is below 80, sessionals will not be allowed. And if who is interested in becoming CR, you can give me the names. You can message me in WhatsApp. Okay, then we'll end the meeting. Have lunch. Take care. Bye.
Bye, ma'am.
Bye, ma'am.
Bye, ma'am.
Thank you, ma'am.
Yes.
Thank you, ma'am.
Thank you, ma'am.